Hello everyone, I am Petunia Fernandes, and I consider it my greatest honor and privilege to be able to talk to you all today via this platform that Speaking Archaeologically has given me. The title of my talk is Zooarchaeology, Introduction and Application in Archaeology, with a focus on the Middle Bronze Age animal economy at Tel Azekah. This is a brief overview of what I'm going to talk about and discuss with you today. First, I will provide a general introduction to the subdiscipline of zooarchaeology and discuss the different nuances in studying this field in the following section. Lastly, I will illustrate the practical use of zooarchaeology by presenting my MA thesis as a case study. Please do bear with me because I will be using a lot of technical terms. I have tried my best to break down these terms, but if in case I haven't, please don't hesitate to ask me about it during the question and answer session. Let's begin a brief journey into the realm of zooarchaeology. As we gaze upon the captivating cave art representation of a bull from the renowned Lascaux caves in France, it is evident that the bond between humans and animals transcends millennia. Animals have touched every aspect of human existence, from being hunted and raised for sustenance and resources like labor, hide, and fur, to serving as companions or adversaries, even appearing as symbols and metaphors in religious and non-religious contexts. Yet, alongside our admiration for animals, lies the uncomfortable truth of exploitation, evoking a sense of guilt in our treatment of them. Given the timelessness of this human-animal relationship, archaeological excavations often yield a plethora of animal remains. Hence, zooarchaeology emerges as the study of these excavated animal remains from archaeological sites. The overarching goal of studying these animal remains is to unravel the intricate interactions between humans and various animal groups within their environments. This pursuit calls for an interdisciplinary approach, drawing upon the application of various physical, biological, ecological, anthropological, and archaeological concepts and methodologies. Scholars worldwide, driven by diverse theoretical interests and backgrounds, have contributed to this interdisciplinary tapestry, shaping the interpretations of faunal data. Understanding the theoretical underpinnings and interests of zooarchaeologists is important in deciphering their interpretations of faunal data. By delving into the interdisciplinary nuances, we gain insight into the complex web of human-animal relationships throughout history. Yet, zooarchaeology does not exist in isolation. It intertwines with broader cultural studies, offering a window into various aspects of human life. To truly comprehend our past, zooarchaeology must merge seamlessly with wider cultural studies, transcending the confines of bones to understand our past. So, how do zooarchaeologists study animal bones and develop a faunal study? And what are the requirements that equip you to study animal bones? I will answer these questions in this section. In the study of zooarchaeology, understanding how animal bones are analyzed and interpreted is crucial. A strong biological foundation is paramount for zooarchaeologists to ensure the completeness and accuracy of faunal studies. This foundation encompasses basic biological and ecological concepts, including skeletal biology, which is constituted by skeletal structures such as teeth, bones, shells, and exoskeletons that are usually recovered from archaeological sites. Taxonomy, which is the classification of living or extinct organisms, animal behavior, ecology, and predator-prey relationships. Once equipped with this foundational knowledge, zooarchaeologists proceed to develop a faunal study. This involves meticulous identification of animal remains, considering factors such as bone type, species, age, sex, modifications by humans by burning or through cut marks from butchering, or with incisions for writing or art, gnawing by animals, and taphonomic signatures, which are related to decomposition and preservation of animal remains. Even fragmented bones are noted, as they can provide valuable insights during analysis and interpretation. Understanding site formation processes and excavation procedures is equally crucial for accurate interpretation. The taphonomic history of a site, influenced by human, animal, and environmental factors, greatly shapes the composition of faunal assemblages. Factors such as human disposal patterns, site function, and excavation techniques can all impact the preservation and recovery of animal remains. Following identification and consideration of site formation processes, zooarchaeologists employ various lines of inquiry using appropriate techniques. These techniques should be carefully chosen to avoid masking or skewing the evidence, considering their respective strengths and limitations. Biological and geological methods form the foundation and are often employed by many zooarchaeologists, but additional techniques are also developed as needed to address specific research questions. Interpreting the results of faunal studies involves synthesizing multiple lines of evidence. Hypotheses and interpretations should be supported by multiple faunal data sets, ethnographic analogies, modern experimental studies, if possible, and consideration of cultural contexts. Additional information may come from petroglyphs, figurines, murals, written records, or other archaeological artifacts. I will now proceed to talk about my MA thesis, which will provide a real world example of how these principles are applied in practice. For my MA thesis, titled Animal Economy at Tel Azekah During the Middle Bronze Age and the Nature of the Settlement, the focus of my research was understanding the urban nature of Tel Azekah during the Middle Bronze Age by studying the faunal assemblage of the site. For my research, I analyzed the zooarchaeological evidence to identify the fruit production systems that supported the inhabitants of Tel Azekah during the Middle Bronze Age. I then explored the dietary and social habits of the people of Azekah and how that reflects the characteristics of an urban center. I also attempted to compare the animal remains from Azekah with those from other sites in the southern Levant dating to the Middle Bronze Age to understand the role of Azekah in the region and its interactions with other urban centers. And lastly, I attempted to add to the diachronic study of published faunal assemblages of the site dating to different periods to understand what aspects of the animal economy continued, what changed, and the possible factors behind these continuations and changes. Now, for the next session, I will proceed to talk about Tel Azekah and the Middle Bronze Age in the southern Levant. This is an aerial view of Tel Azekah looking northwest. This site is located at the heart of the Shephelah, a transitional region of hills and valleys in south-central modern Israel that separates the coastal plains to the west from the Judean highlands to the east. Tel Azekah boasts a rich history shaped by its favorable ecological conditions and strategic location, acting as a vital buffer zone connecting the Shephelah with Canaan. This region served as an agricultural hinterland for urban elites and a key point of control for cities and towns in the region like Gezer, Tel Beth Mirsim, Tel Lachish, and Tel Es Safi Ghat. Situated 27 kilometers southwest of Jerusalem, Tel Azekah overlooks the Elah Valley, surrounded by natural defenses on three sides. You can observe the steep slopes on all the three sides of this mound on the picture, as you can see. Its pear-shaped mound, spanning 11 acres, commands a strategic junction of roads linking Tel Es Safi Ghat in the west to the Judean hills in the east, and Beth Shemesh in the north to Lachish in the south. The site's excavation history dates back to 1898, when British archaeologists F.J. Bliss and R.A.S. McAllister, representing the Palestine Exploration Fund, uncovered two distinct periods, Israelite and pre Israelite, spanning the first and second millennium BCE, respectively. Subsequent surveys by Dagan in the 20th century CE revealed occupation from the early Bronze Age 2 to 3 to the Byzantine periods. In 2012, the Lautenschlager Azekah expedition commenced renewed excavations led by researchers from Tel Aviv University and Heidelberg University after subjecting the site to a thorough above-ground archaeological survey and a ground-penetrating geophysical survey. Over 11 seasons as of the summer of 2023, ongoing excavations have unearthed new insights into the site's history and significance. Tel Azekah stands as a testament to the region's enduring importance as a crossroads of civilization and a focal point of archaeological exploration. To streamline our discussion, I won't delve into the detailed terminology and chronology of the Middle Bronze Age in the southern Levant, as that warrants a separate discussion. However, it's important to note that this period signifies a resurgence of urbanization and growth following the non-urban hiatus of the Intermediate Bronze Age. Scholars commonly characterize it as a time of re-urbanization marked by the emergence of central fortified centers surrounded by villages and cult places with vibrant material culture. For my research, I have adopted the absolute chronology proposed by Hofmeier in 2017 due to its balanced approach between absolute and relative chronology. This chronology aligns well with the tripartite terminology proposed by Dever in 1987, which designates the Middle Bronze Age as consisting of three phases: 1, 2, and 3. Moreover, Dever's terminology enjoys support in scholarly circles. Notably, the excavators and researchers of Tel Azekah also adhere to this chronology, facilitating alignment with their work. Therefore, the chronology I adopted for my research is Middle Bronze Age 1 from circa 1900 to 1800 BCE, Middle Bronze Age 2 from circa 1800 to 1700 BCE, and Middle Bronze Age 3 from circa 1700 to 1550 BCE. Tel Azekah played a pivotal role in the political and economic landscape of the Shephelah, the Judean highlands, and the coastal plain during the Middle Bronze Age. As of the time when I wrote this thesis, which was in 2021, findings from this period have been unearthed in 8 excavated areas, which you can see in the map which I've provided on the slide. These areas are E3, S1, S2, S3, W1, W2, W3, and N1. The Middle Bronze Age occupation at Tel Azekah is delineated into 3 main phases based on monumental construction, each characterized by distinct architectural features and multiple subphases. The White Flows ceremonial building in area E3 lower serves as a hallmark of the Middle Bronze Age 1 to 2 phase, which is from circa 1900 to 1800 BCE. Though lacking a complete in situ plan of the whole structure, remnants of its distinctive white flow suggest its use for elite activities or monumental ceremonies. Additional findings, such as a large number of animal bones, storage jars, decorated local pottery, and imported wares in a secondary context, support this interpretation by the excavators of the site. The Middle Bronze Age 2 to 3 phase from circa 1800 to 1700 BCE is marked by the construction of a fortification wall enclosing most of the site, This is a picture of the fortification wall from the northern closing wall in area E3. The wall measures 2.5 meters in thickness and 2.84 meters in height, and this wall was built following the abandonment of the White Floor ceremonial building from the first phase of the Middle Bronze Age in Tel Azekah. The wall also consists of a stone foundation with mud brick superstructures. It was revealed in 6 excavation areas in the shape of an inset-offset fortification wall, particularly in areas N1, W1, and W2. Inset wall is a descriptive term indicating that a section of the wall protruded forward outside the main line of the wall, then the next section was recessed, following by another section jutting out. The third and final phase of the Middle Bronze Age in Azekah, which is the Middle Bronze Age III from circa 1700 to 1550 BCE, is represented by the bastion, a monumental structure partially built atop the remnants of the White Floor's ceremonial building, using the previous building materials of the same building. This bastion is located on the southeastern slope in area E3 lower. Its construction reflects a shift in architectural focus and strategic orientation at the site. According to the excavators of the site, the public architecture of Tel Azekah during the Middle Bronze Age provides insights into the fluctuating social and political dynamics of the period. While the Middle Bronze Age 1 to 2 phase suggests conspicuous elite consumption and intra-regional economic relationships in the Shephelah, marked by the findings of significant amounts of storage jars, the presence of elite wares consistent with feasting, and locally produced red, white, and blue wares from the White Floor ceremonial building, the fortifications of the Middle Bronze Age 2 to 3 phase may indicate a focus on reinforcing the local Azekah society. Interestingly, no more imported and decorated potteries were found, and most findings were associated with the fortification of a domestic nature. The appearance of projecting bastions in the final phase of the Middle Bronze Age reflects a broader trend of the revitalization of intra-regional activities in politics and economics, since the appearance of projecting bastions can also be seen in other sites such as Tel Batash and Khirbet el Yahud Batir. Furthermore, these contemporaneous architectural phenomena emerging in the southern Levant might have indicated growing regionalism, which is a significant character of the Middle Bronze Age as contrasted to the Early Bronze Age. Now that I've given a little background of the Middle Bronze Age and about Tel Azekah, I will move forward to the methodology that I employed for analyzing the faunal assemblage. For my thesis, I analyzed the faunal assemblage utilizing a variety of methods and data analysis techniques. Faunal remains under examination were excavated from the renewed excavations of Tel Azekah, spanning the years 2012 to 2019, focusing specifically on faunal remains from secure and defined loci belonging to the Middle Bronze Age. These faunal remains are associated with the monumental architecture of various phases within the Middle Bronze Age at Tel Azekah, which I spoke about previously. Since the understanding of the various phases of the Middle Bronze Age in Azekah at the time of writing this thesis was still developing and not final, my research combined the dataset and analyzed it as a unified representation of the Middle Bronze Age. The excavation areas yielding faunal remains included Area E3, comprising upper and lower sections on the mount's southeastern slope, Area N1 on the northern slope, Area S1 on the southern slope, and Area W1 on the western slope. Faunal remains from Area E3 were retrieved from constructional fills associated with the White Floor's ceremonial building and the later phase bastion, as well as fills related to the second phase fortification wall. In Area W1, the faunal remains originated from construction fills of the second phase fortification wall. Area S1 yielded faunal remains from the floors of an unidentified structure, while Area N1 provided faunal remains from a refuse pit containing a nearly complete donkey skeleton, pottery, and flint blades. The settlement plan and density of Middle Bronze Age Tel Azekah remain elusive, though recent excavations have begun to shed light on this. Most faunal remains were collected manually from 4 by 4 meter squares, with some squares enlarged to 5 by 5 meters where necessary. A subset of bones underwent wet or dry sieving. Following excavation, all the bones were cleaned using toothbrushes. Each skeletal element that could be identified was meticulously recorded on an Excel spreadsheet. This picture I clicked when I was analyzing bones. As you can see in front of my laptop are sample bones, which are used to help me identify bones that I have for analyzing myself. And each of these bones were, were recorded on an Excel spreadsheet following the methodology of Sapir Hen et al. The data recorded included a number assigned to each fragment, the fragment area, square, loci, and basket number to keep track of the context from which the faunal remains were retrieved. Other data included taxonomic identification, which is species identification, completeness of element, whether the element or the bone is broken or is fragmented, fusion stage, which is aging, presence of cut marks, burning, weathering, pathologies, and measurements where applicable. Unidentifiable fragments were tallied separately. In this picture, as you can see, I have written the number on the bone. So when I start identifying a bone, I first identify all the parameters that I talked about above, and then I write a number on the bone and put it back in the same packet from which it came from so that I don't disturb the loci and the basket numbering. Taxonomic identification was pursued to the lowest possible level, drawing from the terrestrial vertebrates collection housed at the Steinhardt Museum of Natural History. For elements unable to be identified to a specific taxon or species, 3 size-based categories were utilized and quantified accordingly. A group was for large mammals, such as cattle and donkeys. B group was for medium-sized mammals, such as sheep, goats, and pigs. And C group was for small mammals, such as dogs. To assess taxon abundance within the assemblage, I utilized 2 common methods, which is the number of identified specimens, in short NISP, and the minimum number of individuals, in short MNI. I further supplemented these 2 methods by using the minimum number of elements, MNE, and minimum animal units, MAU. These methods help to compare the assemblage over time and space and are often used to supplement age and sex ratios, to find out specialized sites or activity areas, and to contrast animal use by different social groups. The NISP counts how many specimens belong to each species based on identification, and MNI is calculated as the highest number of times a certain skeletal element of a taxon appeared in a collection. However, the usage of these methods comes with their own problems. The main problem with using NISP is that there is an inherent bias if some of the taxa involved have more identifiable bones per individual bones than others. This usually happens when during excavations, minute bones are often overlooked and big bones are normally collected. So that usually forms a huge part of the collection. This bias can then be reduced by using the MNI method. MNE is the smallest number of complete bones that can account for all the specimens observed as defined by Lyman, while MAU stands for the minimum number of animal units required to explain the specimens in a collection, as defined by Lyman again. To calculate MAU, the MNE of each element is divided by the number of elements expected in a complete skeleton. Please bear with me, it will get more technical now. Estimating the age of death of an animal helps to reveal how animals were exploited in the past and how that affected societies and their economies. Two commonly used methods for estimating the age at death of animals are the analysis of epiphyseal fusion, which is the end of the bones that connects to other bones. So if it's not fused, you can assume that the animal was a young animal, but if it's fused, then it was an adult animal. And for that, you need to know the, the age of fusion for each species that you're studying. And teeth eruption and wear is also studied. And for all of these analysis, you need to study different sources because for different species, the age of epiphyseal fusion and teeth eruption and wear differs. Here I have an example of a caprine maxillary tooth. Caprines are sheep and goat. The tooth where an eruption is normally identified by the crown of the tooth. Differentiating between the sexes in faunal assemblages helps to identify sex-based preferences in husbandry strategies, predator-prey relationships, and food preferences. In some animal species, specific skeletal elements can be used, like the canine teeth in pigs and equids. The distal epiphyses of the humerus can be used to sex ungulates like goats and sheep, and the iliac and the pubic regions of the pelvis can be used to sex whole or fragmentary specimens. If you can see my arrow, this is the iliac version of the pelvis, sorry, the iliac region, and this is the pubic region of the pelvis. I'm sorry, 1 minute. In some animal species, uh, in some mammals like goats, cattle, and fallow deer, the forelimbs that support heavy appendages like horns and antlers can be used to determine the sex of a specimen based on differences in size. However, for my research, I could not find any element that could be measured to distinguish sex, which is a drawback of my thesis because sexing bones can also provide a big picture of the animal economy. Analyzing skeletal elements involves measurement of the bones to distinguish between similar species, determine sex, and investigate how they are affected by factors such as climate change, breeding patterns, and overhunting. All measurements were taken by following the method of Van den Reich and by using a digital caliper with 0.01 millimeter accuracy, which you can see in this picture. The measurements following Van den Reich explains which part of the bone should be measured and how that is helpful in determining all the points I mentioned above. And this can only be done with complete skeletal elements. Bones were also examined for signs of diseases and injuries called pathologies, for butchering, burning, animal-induced marks, and for signs of weathering. Diseases and injuries can be caused by genetic factors, environmental stress, infections, abnormalities, or intentional or unintentional trauma. Studying these signs can reveal information about the animal's health and diet, how they were cared for, and the cultural attitudes associated with them. The method used to identify and analyze these signs in the bone collection was again based on Sapir Hen et al. Their work was published in 2008. This bone in my faunal assemblage collection is a bone belonging to a pig. As you can see here, it's an unfused bone, and the pathology is marked by this black arrow over here. I identified the pathology as osteomyelitis, which is an inflammation of the bone. The causes, however, could not be determined for the inflammation. Butchering is the process of turning an animal carcass into edible parts as defined by Lyman. Different kinds of animals may require different steps and sequences of butchering activities from the acquisition of the carcass to its final disposal. Butchering marks were analyzed using Binford's typology, which he published in 1981. This typology distinguishes between skinning, disarticulation, filleting, and meat removal from bones, which are different stages of preparing meat for food purposes. In this image here, you can see a radius of a medium-sized mammal, which I found in my faunal assemblage. And you can see how many cut marks were found on this specific bone. Animal-induced marks on bones provide information on human disposal practices and the presence of scavengers and predators at the site or near its vicinity. The pattern of gnawing damage caused by different species is distinct and can be identified as such. In this picture of the ischium, which is a part of the pelvis of a caprine, you can see a circular gnawing mark here. I failed to identify which species caused this gnawing mark, but it was interesting enough to mention in my thesis in the appendix. Bones that have been altered by fire can reveal how people used fire for different purposes, such as cooking, disposing of waste, making offerings in ritualistic settings, or other activities. Bones that showed signs of burning were classified into three groups based on their color changes. B negative for bones that were slightly charred but not distorted. B for bones that were partially incinerated and had black color and cracks. And B positive for bones that were fully incinerated or calcined and were white and blue in color due to exposures to very high temperatures. Weathering is the term used by Besson-Mayer to describe how bones lose their original microscopic structure and composition due to physical and chemical factors that affect them on the surface or in the soil, which is decomposition. Besson-Mayer proposed 6 stages of weathering for large mammals weighing over 5 kgs, and that reflects the decay of bones over time. These weathering stages were used to examine and interpret the taphonomic processes of the skeletal elements of the assemblage I studied. This thorough analysis of the assemblage helped me form my results and then interpret the data accordingly. For my interpretation, I delved into understanding Tel Azekah's urban nature, food production system, and regional significance during the Middle Bronze Age. By examining the faunal assemblage of the site, I aim to uncover insights into dietary habits, social organization, and the site's overall role, as well as to add to the diachronic study of faunal remains at the site. During the Middle Bronze Age, domestic livestock, particularly caprines, dominated Tel Azekah's animal economy, followed by cattle. Gazelles, a wild mammal species, were also notable in the assemblage. The analysis of caprine mortality profiles using the NISP method and the MNI methods suggests a focus on specialized meat production, especially evident in the culling of subadults. The prevalence of goats over sheep likely stemmed from their adaptability to the region's arid conditions during this period and their reproductive capacity. The high number of goats could also be attributed to the twin factors of intensive agriculture and high settlement density. Furthermore, my research revealed that cattle were primarily culled for meat during their young adult stage and were utilized for traction purposes in their adult stages. While the findings of this study suggest a focus on meat production, it's challenging to determine if secondary products were a goal due to the limited remains of animals from an older group and the inability to sex faunal remains. Despite caprines and cattle being the primary focus, other species such as pigs, donkeys, wild mammals, birds, and fish were also exploited, albeit to a lesser extent. It is important to mention that the study of donkeys during the Middle Bronze Age is a part of a separate thesis because of the prevalence of donkeys in burial contexts. So this was out of the scope of my thesis, but is still a very interesting topic to consider. This feature of burying donkeys is prevalent in the early Bronze Age as well as the Middle Bronze Age, and then it faded out during the Late Bronze Age. The presence of birds and fish in the assemblage was too insignificant to glean any meaningful information from. It is then safe to assume that Tel Azekah possessed a self-contained economic system where domestic livestock was locally raised and utilized during the Middle Bronze Age. Furthermore, my analysis of the faunal remains in relation to site context showed limited evidence for social stratification or spatial division. The majority of the faunal remains analyzed in this study were retrieved from a fill context associated with the fortification walls in Area W1, closely followed by Area E3. Meat-bearing and non-meat-bearing elements were distributed relatively evenly across site areas, suggesting equitable resource distribution. This interpretation is also supported by the mortality profiles of different species, which is spread across all areas that were under study. The presence of the remains of wild mammals further suggests the affluence of the site's inhabitants, as it is suggested that wild mammals were only hunted by elites. But however, it's important to note that interpretations may evolve with new excavations, and which has happened in my case because the recent excavations that happened in last year's season and in the 2022 season changed the interpretation of Area W1 especially, where they now conclude that the area was not a fill, but rather a fortification wall. But since I had already written my thesis, I was asked not to make those changes. Recent discoveries at Tel Azekah have already challenged some previous interpretations, underscoring the dynamic nature of archaeological research. Architectural and material finds from the Middle Bronze Age indicate Tel Azekah's importance in the economic and political landscape of the regions of the Shephelah, the Judean highlands, and the coastal plain, serving as a secondary urban center controlling trade routes owing to the prosperity of the port settlement of Ashkelon and the economic opportunities it presented, as suggested by Stagier's port power theory. The urban nature of Azekah during the Middle Bronze Age is further supported by the presence of locally produced red, white, and blue ware, which has been meticulously researched and documented in another thesis by Quayle Gates. While many aspects of Tel Azekah's animal economy aligned with the self-contained economic model proposed by Wapnish and Hess in 1988, Zeder's hypothesis views Azekah as a rural settlement. However, understanding Tel Azekah's urban nature requires considering unique regional factors influencing urban development, as Zeder's thesis focused on a site in Iran. And even though both of these sites are in the southern Levant, the conditions affecting each site is different. So studies like these should be carefully used, but still provide a useful comparative analysis anyways. Comparing Tel Azekah's animal economy with contemporaneous southern Levantine sites reveals commonalities in the dominance of domestic livestock, particularly caprines, emphasizing specialized meat production and the presence of monumental architecture. Despite shifts in sheep to goat ratios and changes in the importance of cattle, the focus on meat production persisted. The presence of pigs and wild taxa in the faunal assemblage of all these sites is also a common thread. The animal economies at Tel Azekah during the Middle Bronze Age and Late Bronze Age III shared similarities. The faunal assemblage of Late Bronze Age III Azekah was analyzed by Jones in 2017. And these similarities included specialized meat production of caprines and the use of cattle for traction. What changed was the sheep to goat ratio, where goats outnumbered sheep during the Middle Bronze Age and sheep outnumbered goats during the Late Bronze Age. But despite this change in ratio, the focus on meat production continued. The importance of cattle increased from the Middle Bronze Age to the Late Bronze Age, and the consumption of pigs abruptly ended. The variety of bird species decreased during this period, as did the number of wild mammals. This period, as in the Late Bronze Age. Tel Azekah during the Middle Bronze Age exercised considerable autonomy over its animal economy. This autonomy was allowed to continue during the Late Bronze Age when the whole southern Levant came under the rule of the Egyptians. The major shift in the animal economy of Tel Azekah during the Iron Age 2B and the Persian period resulted from imperial control. And the animal economy of Tel Azekah during the Iron Age 2B and the Persian periods was studied by Colin in 2020. For instance, in the Iron Age 2B, Assyrian control led to a preference for sheep over goats, driven by the demand for specialized products. Similarly, in the Persian period, Azekah continued to remain under the hegemony of an empire, but this time it was the Achaemenids. However, for the Persians, Azekah and the region of the Shephelah were not as important as the coastal plains, which would explain the smaller settlement size and a shift towards specialization in meat production. Changes in Tel Azekah's animal economy from the Middle Bronze Age to the Persian period were influenced by external control, shifting from autonomous systems during the Middle Bronze and Late Bronze Ages to imperial rule during the Iron Age 2B and Persian periods. Instead of environmental factors, in this case, historical factors played a key role in shaping animal husbandry practices. These changes in animal husbandry practices suggest increased social complexity over time. So, to conclude, Tel Azekah emerges as a significant secondary urban center, strategically positioned to control trade routes within the Shephelah for its benefit. Fortifications, public architecture, and ceramics further support this assertion. Its self-contained animal economy underscores its autonomy during the Middle Bronze Age, like other sites in the region, although interpretations continue to evolve with new discoveries. I did my best to contribute to unraveling the enigmatic history of Tel Azekah's occupation during this pivotal period, and I hope that using my MA thesis as a case study provided the practical use of zooarchaeology in the larger field of archaeology. Thank you.